let's get started. Before actually talking too much about Flite, I want to talk a little bit about like how Frame currently works and how it's parameterized. Especially about this parameterization, which I think is a lot of like source of complexity and then confusion for people. And forget about all the macros and stuff and just start from scratch and see like why it is the way it is. So in all of the like frame macros and so on that we build, we always start with this. We have like some struct, and usually we call it pallet. And this guy exists, and we create an implementation block for this guy. And at some point, we want to attach some functions to it. So let's say this pallet is going to be some kind of a cryptocurrency, and I want to add like a transfer function. Let's imagine it's like this. From is a static string, to is a static string, and amount is a U32. Something as simple as this. Oops, I think I have a bit of issue here. Okay. And the first sort of like point of confusion with Frame or point of complexity is that when Frame was created, we wanted especially the different types to be parameterizable. So for example, here I'm kind of hard coding, okay, the amount that I'm transferring is represented as a U32. But this is actually not like a very large numeric value. Maybe someone else who's using Frame wants to use U64. Maybe someone else wants to use U128. So let's make this parameterizable so people can choose what they want themselves. And how we could naively do this is to say, okay, Rust is a language that supports generics. So I can actually create such a type. I can come to this struct balance and say, hey, you have a, this struct called palette and say, hey, you have a generic type associated for it. And similarly in the implementation block, I can say, hey, for any balance type, implement some functions for this struct of balance. And then I can specify that this amount is of some generic type balance. In fact, if I want to make it a bit cleaner, I would call it just B. The convention is to use single character names for generic types. And then another sort of customer or user might say, hey, I actually also want to parameterize this from and to type, like the account ID type that my palette has. So we can come and say, okay, we're going to add another generic to this, A, which stands for account ID, and add it everywhere. So it would look something like this. And instead of this static string guy, we would use this generic type A. So this in itself actually works, and there's no issues with it. The problem that you can probably imagine would arise eventually is that if this palette is now parameterizable over like 10 different things, it becomes quite ugly. It becomes quite a pain to manage all of these 20 generic types here. Like imagine there's A, B, C, D, E, F, all this different like generics with different meanings. So this is like the first version of our thing. By the way, this, whatever I have so far is perfectly valid Rust code. Like this little snippet of 4 lines is perfectly valid code. But now let's take it a step further and improve this a little bit. Let's go to like palette v2 and improve this a little bit. So one of the first things that we do in Frame quite often is to say, okay, if I have like 20 generic types, I can actually simplify them by combining them into one type, and that type would be a trait. I will show this now. So let's first refactor this into palette v2. And I mean, in this example, I'm using just A, B, and C. So A and B. So it's only 2. But again, in your mind, imagine it's 20. So it's going to be very difficult to like name all the 20 here. So what I can say is okay, I have like one trait called configurations. And this trait has an associated type A and another sort of associated type B. And instead of like naming A, B, C, D, E, F, G, blah, blah, blah here, I'm just going to say this guy is generic over something, some T, and this T has to implement config. And then I can access the same sort of like type that I was accessing before with this syntax, t.a, t.a, t.b. Right? Like this trick, this syntax is just a shorthand to help us combine a lot of types inside of one trait and make our palette struct generic over that one thing rather than generic over 20 things. So that's one of the first like tricks that we use in Frame. Then, again, feel free to ask any questions in the meantime, but if not, I'll continue. Then we use another Frame sort of like another Rust syntax to help us, which would be to say, okay, all palettes want to be sort of generic over, or all palettes inherit some configuration from a shared set of configurations. In Frame, we call this frame system. So let's take our code example here. Actually, let me also make it a little bit better. I don't like this so far. So this A, what I mean by it is account ID, and B is balance. So here my syntax would look like account ID and balance. I mean, in fact, if I wanted to be a bit nicer, I would also rename these guys again to account ID and balance. So far, this code and this code is pretty much the same. The next thing that we want to do is imagine in our system, there is a set of configuration. I will call it shared config. But those of you who have already coded something with Frame, you know this is like Frame system. Like shared configuration for all modules. So imagine there's some shared config, and how do we deal with that? I mean, one thing we could do is say, hey, my palette, and imagine our shared config has like one type. I think I need to update these guys a little bit. So I'll bring the latest version down here. So it has the full name, account ID, and balance. And imagine in our shared config, we have a few more types, like, I don't know, type, block number. And I don't know, type, what else is there? Timestamp. What we could do naively is say, okay, every module, every sort of palette, I'm going to call this one V3, is generic over two things: a T that is my configuration, and let's say an S that is the shared configuration. And it would look something like this. And now imagine inside of my code, I want to access something from, when I wanted to access something from T, I would say T account ID. Now I want to create something like current block number, and I want to assign to this type, ::block number. And the implementation doesn't really matter, so I would leave it to do. Right? This also works. Again, 100% valid Rust code. In fact, I can try and compile this. I think I had a terminal, or how do I open the terminal here? Let me, here, cargo check. Oops, actually, no. I probably have a bunch of like, okay, I'm redefining stuff. Okay, so trust me that all of this stuff compiles and it's valid Rust code, but it actually is not compiling because I have multiple versions of it. I guess what I can do is I can put them in different modules. V0. I'm going to spend a little bit of time cleaning this up because I think it would be useful if we can share this code with people afterwards. So in this V1, we're going to have this guy. And then in our V2, we're going to have this guy. Now I should be able to get closer to compiling it, and it's actually working. Is this not the same? Unused? Is this the same compilation? Used. Okay. Okay. You need to do some things to make the Rust compiler as always happy. You need like a phantom data of account ID and balance here to kind of satisfy the beloved compiler. Same here. DD marker phantom data of T. And same here. DD marker phantom data of T and S, which we can put in a tuple. And I think if I'm going to embarrass myself too much, this should get closer to compiling. Not used. But I did put it in a... it's not saved, sorry. And then, finally, yeah, okay, this is also valid. Plain, finally it compiles. Okay, so this was just a quick sort of testimony that so far everything I'm writing is valid Rust code. I'm just, I'm playing around. Okay, so in the last version, we had our configurations T and some kind of shared configuration. But truth is, this is actually a little bit unnecessary as well. I can copy and paste the whole thing and call it V3 this time. Right? We have V0, V1, V2, and now we're at V3. And this is not necessary, or we can simplify this by using a different syntax, which prevent us from needing to define two generics by using the super trait stuff. So basically this syntax to say, hey, anything that implements this configuration must also implement the shared configuration. And with this trick, I can only have one generic here. I don't need two. I can get rid of this T because it's no longer necessary. Because this T now is a representation of both this config trait with these two types. And it also has, in its belly, this shared configuration as well with this super trait syntax. This is kind of like inheritance in Rust. You're saying, hey, anything that implements this trait must also implement this. So you basically know both of them are implemented. So I can get rid of this S everywhere. And now instead of S block number, I would say T block number. And if I compile this again, I am good. Okay, let me add some little piece of code here to say, what was the syntax? Like this, I think, allow warnings. So the compiler just doesn't complain at any warnings. Okay, so this is actually pretty similar to how Frame works so far. So we usually have one configuration per pallet. And if we look at any Frame pallet code, you see that this pallet's configuration is usually bounded by the frame system configuration. And that's all good so far. This is a legit way of going about doing things. But then I want to talk about two complexities. So let's write it down. Two issues. I mean, these are design choices of Frame that were made even before I started working in it. And over the years, I learned that these are trade-offs. This simplified the syntax, what we have done so far in V0 all the way to V3. But truth is, this V0 has some advantages compared to the former one, to the last one that I'm going to talk about right now. So we have two issues. One is that we cannot define any defaults. And second is that syntax is sometimes terrible. Now, let's first start with this first one. Syntax is sometimes terrible. So if we look at this code, like this piece of the code, when I type T : account ID, Rust compiler can figure out that, okay, T is something that implements config and shared config. And it can figure out that, okay, account ID is actually coming from this guy, so it's all good. I can access it. And whenever I type like T : block number, it knows that, okay, T implements, again, both of these traits. And block number is coming from the shared config. It's all good. Rust compiler can figure that out. But problem is, if there are naming conflicts between the two, then the Rust compiler cannot figure that out. And you have to use a syntax that I found over the years many people find quite confusing. So let's look at an example of that. And let's say I have a type account ID here as well. I heard a noise. Does anyone want to say something or give a comment? Okay. Seems like no.
Someone joined.
Someone just joined.
Okay. Okay. All good. I'll continue. So now I changed something here, and I added type account ID to both shared config and this palette level config. And this is where the Rust compiler is going to get confused, because if I try and compile this again, it would give me a error message where in this simple example is actually a very good error message, but in Frame, because we have so much nested traits and types, sometimes the error message is a bit hard to understand. It's telling me, hey, this type T account ID is ambiguous. I don't know from where to get it. And it's even telling me from what candidates I have. It's saying T account ID could either come as T as config or T as shared config. And please specify which one you mean. And this is a very, very important syntax in Frame that because of these design choices, we have to be familiar with. So if I want to fix this, let's leave an example here. The golden syntax, I'll call it the golden syntax, is type as trait : associated type. So in our example, the type that we're talking about is T. And then we have to specify T as what trait, which is implemented by T. And then we can access the associated type. Like these guys are called associated types of that particular thing. So here, instead of T : account ID, to disambiguate it for the Rust compiler, I have to use a syntax like this. T as either shared config or config. So let's actually do one each. I'm saying either this type T as this trait or as another trait. You know, in Frame, you very often see this very janky syntax balance off. And it usually equates to something like T as config, currency, and this is itself a type. And then we wrap the whole thing as trait currency balance. Like this is just it's a two-level nested version of what we just saw here. Okay, so this is one of the complications. Syntax is sometimes terrible when we use this trait so much, but it's manageable. I think it's just like once it clicks for everyone, it clicks and then you're good to go. But we have made another compromise along the way as well, which I think is more worthy of talking about. These associated types that we can put inside a trait, you cannot specify a default for them. You cannot say, hey, type account ID is something that someone can parameterize, but it's always U128 if not specified. This syntax just does not exist in Frame. In Rust. It's something that people haven't added to Rust yet. There is like some RFC and some plan for it to add it eventually, but it's not there at the moment. And it's interesting to realize that this is a little bit a step backwards because generics can have a default. You can have a generic like this to specify a default. This is just a trade-off that we have taken. So let me try and give an example of this. So I had in this V0 a balance type, and I can actually say, hey, if this is not specified, it's always U128. And then, for example, in my main function, I can say V0 palette. I think I need to make everything public. So obstruct. when I want to create an instance of this pallet, so we say v0 pallet, and this pallet, if we remember, it was generic over an account ID and the balance, but the balance actually has a default. So I can only specify the account ID, and let's say it's v32, or I don't know, static string. And then I can call the transfer function on top of this. I need to make the function also public. I didn't think about making stuff public. Then I can call the transfer. And you can see already the Rust analyzer here is also figuring out that, okay, the from and to are static strings because I parameterize it here. And the balance type is U128, this amount, because I'm specifying the default. And if I want to override it, I can, of course, override it. And now this amount is U64. I think we might see it here. Yeah, balance is U64. So what I want to point out is that actually, let's try and complete this as well. So Jesse, and we transfer a 10 unit of U64, whatever. And again, this should all compile. It does indeed. But conveniently, I can do the same without specifying this. And now this would also work, but right now it would give me a compiler error because this 10 should be U128 because the default for the second generic balance was U128. But I cannot really do this with the second approach. I cannot really do this in this approach. So let's try and utilize our v3 palette struct. So let me make all of these guys public. Struct and pop fn transfer. So how do I build a v3? First, I would specify something like struct runtime. Again, this is like the name we use in Frame, but it could be anything. It's in essence, it's a configuration. And then I implement v3 shared config for configuration. And I have to specify type account ID, let's say it's U64, type block number, also U64, type timestamp, also U64. Doesn't really matter. And then I have to implement this v3, the local config, which again has a type for configuration. And this guy again has type account ID, let's say this time U32, type balance, U32, doesn't matter. But as you see, I don't have an option here to specify a default. Again, this trait config, there is no way to say, hey, this guy defaults to U32 if not specified. You have to parameterize it. And then finally, I can call my v3 palette. And if you remember, this v3 palette was generic over some T that implements both shared config and the config, which in this case is struct configuration. So it would look like this. And then I can call my transfer function. Yeah. And then you have to specify the types correctly and so on. But okay, so I wanted to just point out that there is a complexity in Frame that we cannot have defaults. And this is one of the things that in Flite we have tried to improve upon. Okay, now I want to familiarize yourself with another syntax that's also important. So let's take our v3 palette and make some modifications for it. And this one is also like a Rust syntax that not a lot of people know about, but it's quite important. And it helps a lot of things, I realized. Okay. So what are we going to do? Let's look at this code, like this line specifically. We are saying, hey, there exists a T which implements both shared config and config. And even though we cannot specify defaults for it, we can simplify it a bit by putting something called constraints on the associated type. So the name of the Rust sort of language tool is called constrained associated type. think we can actually Google it and find some examples of it. Is there some example of it? No, this is not the one I was looking for. Okay, I mean, I'm not finding an example, but I'm pretty sure that is the name. Or maybe I've forgotten something different. But anyways, constrained. So what is constrained associated type? You can say, hey, I'm generic over any T that's config, and that's all good. But you can add some constraints here and say, but I am only generic over some T that is config, and the balance is U128. And this basically tells the Rust compiler in this block of code, this, T as config balance is always U128. Otherwise, the Rust compiler wouldn't allow the code to even compile. And this allows you to not need to, deal with all of these generic types. And instead of typing like T balance, you can just say U128. And your code is perfectly valid in this case example as well. I mean, we can again try and compile this again. As you saw, the whole thing compiles. So this is completely valid Rust code. And where can we use this? We can actually use this a lot in Frame, because in Frame, all pallets are generic over this Frame system. And we can put some constraints on it and simplify some things. Okay, I think that's the end of my Rust playground and coding. I will pause here for another minute to see if anyone has any comment or question, and if not, I will go to describing what Flite is doing. In short, Flite is leveraging this knowledge that I just shared and these techniques to simplify Frame in a way that the syntax is a bit more approachable.
Yeah, I was about to ask a question. This constraint associated type, is it somewhat similar to like defaults in config, like when one wants to implement it for like the runtime? Is it somewhat similar?
Yeah, it's less of a default, but I think a good way to I think the word constrain is actually good, because it's saying I can be generic over any config, and this config can parameterize what is the account ID and what is balance. But in fact, I'm saying the balance must be this. So let's try something actually. So what was this? This was V4. Let's change this to V4 and try and do something. So let me change all of these guys to U64 for simplicity. So now let's just say V4 palette and give it this configuration and try and call our transfer function. So from and to are both account ID, which is U64, so I can put 10, 11. Amount is also just a number. I can put 12, doesn't really matter. But this is not going to work, and why? So remember, in the V4 palette, so this guy, I said I can be generic over any T that implements this config trait, but the balance must be U128. Whereas here, I'm passing U64. And now the Rust compiler is going to yell at us. And again, the error message is relatively good. It's saying, hey, a function transfer exists, but its straight bounds are not satisfied. And it's also pointing out to what is actually not satisfied. It's saying, hey, this balance equal U128 is unsatisfied. I couldn't satisfy it. And the only way to satisfy it is to like put U128 here. And then it would compile fine. But we care less about like what I'm putting in the main function. And it's more about what I'm putting here. So basically in this code block, I am freeing myself from needing to think that, balance is some generic type, and I don't really know what this generic type is. And I need to like, if I want to add it together, I need to go specify another trait called, I don't know, std ops add, and deal with all the complexities of generics and just say no. Balance is U128, or else the Rust compiler is not gonna let this palette even compile. Okay, good. Thank you for the question. Let's check again that this works. Okay, now I think we can go into Flite and see what are the ways in which it's working. So I've written like some documentation for this, which is like Rust documentation, and I have it hosted here. I'll make it a bit bigger. And I will then walk over it and show you both the written docs and also the code that corresponds with it. Okay, so this demo called Flite is relying on a number of techniques, some of which we already talked about, to simplify frame. So the first one is when we define a frame palette, by default, we have to make it rely on frame system. And that is, a constraint that we have. But there exists actually a macro helper that would tell the frame macro system, hey, relax this check. Let this palette not rely on frame system. And this is useful for us. We will leverage this at some point. And the macro looks kind of like this. So if I go back to my code, I have a example palette that has been built with Flite instead of frame. And you can see it is leveraging this macro. And this allows me to say, hey, I have a palette that relies on something else. And I called it Flite system in my example. But it's just saying to the frame macro that, hey, it's something different. Okay, so this is one of the techniques. The other one is exactly this constraint associated types, the one that we just talked about. So this is also a technique that is useful. So I have a more comprehensive example here. Very often in frame, we have a syntax like this. There is a trait called currency somewhere, and it has an associated type called balance. And then imagine there's a get function that returns the balance to me. And if I want to call this in a normal fashion, it would look like this. And it's quite ugly. I would tell that, okay, I am generic over some type called currency that implements this currency. And then if I want to call it, I have to say something like self as currency, colon, balance. And this is like just a terrible syntax. Whereas if I use this constraint associated type, I can just say this, that, hey, I'm generic over something called currency. It implements the trait called currency, and the balance is always U128. And I can just then write this. So I know in this code block, this balance type is always U128. So this is another technique that is used in Flite. Mm-hmm. Another sort of like small technique that is used is that very often in frame, we wish to keep palettes as separate from one another as possible, so that we write them completely in isolation. And then if we want them to communicate to one another, we sort of like bundle them together in the runtime level, and we create some traits to allow them to talk to one another. Put more concretely, it's kind of a anti-pattern in frame to have something like this. Have one palette and say, hey, this palette relies on this, and I don't know, another palette. I don't know, what palettes do I have here? Palette, balances config, and palette, I don't know, timestamp config, and so on. But if you use this syntax, you're basically tightly coupling the palettes together, because you're saying whatever runtime, like basically you're saying I only can exist in a runtime that has these two palettes in it as well. The benefit of it is that you can then access these palettes directly, but the downside of it is that now you're tightly coupling them together. And in Flite, we actually want to use this to our advantage. And I will show you in a minute how we actually do that. Okay. So what is our goal? First, so I want to combine all of these techniques together and create something called Flite system. That is like a normal palette, but it's meant to replace frame system. And this Flite system would look like this. It's a palette that itself relies on frame system, but it puts some constraints on frame system, saying, look, I don't care about account ID type being generic. Just give me a 32-byte account ID. Like it's like a voice of frustration, you know? It's saying, I don't care about account ID being generic. I am working in a normal blockchain. I just want my account ID type to be 32-byte account ID, like 99% of the blockchains out there. Similarly, this Flite system is saying, hey, I give you also a instance of palette balances, and I'm putting further constraints on it. As I'm saying similarly, the balance type is just some predefined type. It's just U128, don't care about it. And to demonstrate further, I'm putting even more constraints on, some other somewhat complicated types that come in. And finally, I'm also bringing with me some of the palettes that are very often used in all runtimes, such as timestamp and aura. So with these techniques combined together, we can build this thing called Flite system. And this Flite system is meant to be a replacement for frame system. So you can write a palette, and by relying on Flite system instead of frame system, you can have a much better developer experience, because Flite system removes a lot of genericity from you. Flite system is like a wrapper for frame system and some of the common palettes in frame, such that it's removing a couple of unnecessary generic stuff. So when we define a palette actually with Flite system, this would be the syntax of it. We have to say, hey, disable this check that enforces me to rely on frame system, and instead allow me to rely on Flite system. So I think at this point, I would like to show you an example. So I built a simple palette with Flite system instead of frame system, and it looks like this. So as you see, we are relying on Flite system, and then we are defining like a transaction. It looks pretty much like frame, but you can notice that when I call ensure signed, instead of getting this like generic unknown type, so the other variant would look like this. Instead of getting like this, I don't know, T as frame system config account ID, instead of getting this generic account ID type that I don't even know what it is, I'm getting a concrete account ID type that I've specified myself. And in my example, it's some default from Substrate, but you can basically have it be anything. You can have it be this, for example, SP runtime account ID 32, which is the most normal account ID type that you can encounter. It's just a byte array of 32 bytes. It's the normal account ID that humans actually want to use. So this is one of the advantages of building on Flite instead of on frame. I'm giving another example as well that I'm simplifying this balance type. So I'm doing some simple currency operations. And as you can see, I can actually now have U128 as my balance type instead of dealing with this nasty balance of T type and so on. Okay, so this is a subset of what Flite aims to do. Simplify palette development by giving you something called Flite system instead of frame system that you can rely on. And Flite system just gives you, more simple interfaces and simpler types to code, basically. I should mention one of the downsides of this is that when we have this account ID type to be actually generic, we can do this trick that some of you may have seen a lot in Frame, in the mock file, when we're creating tests, we can actually not use a 32-byte account ID and just use an integer. And that's a nice addition. But at this point, we're compromising on that. We are throwing this aside for the benefit of having a simpler syntax here. As they say in engineering, especially in software engineering, there's no right solution. It's all trade-offs. And in this case, we're also making another trade-off. Okay, so this is most of Flite. And then beyond this, Flite demonstrates one more, I would say, benefit. And this goes back to a feature that we added about 2 years ago to Frame. It kind of looks like this. Let me find an example of it. So this is just like the Rust documentation for Frame and so on. And we added an option to Frame such that we basically mock or add this feature of adding defaults to associated types to Rust at the Frame level. So as of 2 years ago, you can create a pallet in Frame and say, hey, look, I have some trait config, and I have 2 types that can be parameterizable. And if you add this with default, you can then actually specify defaults for them. And you can skip some of them. So in this case, we're saying, okay, this guy actually has a default, and this guy doesn't have a default. It always has to be specified. And the overall syntax is actually pretty good. You specify this here, and then you specify the actual default values, so like a default for the simple type somewhere else. And then you use another macro called the reimplementation. I'm not sure if the documentation for it is great. You can use this derive implementation to basically inherit all of those defaults and only override the ones that you want to override. So it kind of looks like this. If any of you have, for example, implemented the Frame system config for some test struct in like a mock file, it has like 30 something, associated types. But by using this syntax, I'm only specifying a subset of them that I want to overwrite, and I'm letting the rest of them go to some default value. So this macro is something that we have added to Frame, and we're also using it here at Flite with Flite. And what is the goal that we want to achieve with this? The goal is that when you take a pallet and actually take it to a runtime, you have too many things that you have to configure and parameterize. And what I always wished to exist, and I tried to create it with Flite, was like, one simple interface to parameterize a few things, and then everything else is taken care of for you. And this is exactly another thing that I'm trying to do with Flite. So Flite comes with, let's call it 2 things. One is sort of like I call it like a master configuration. So these are things that Flite actually wants the users to parameterize and configure. And they are reasonable things, like what is the block gas? What is the block weight? What is my block time? Is this a 6-second block time or a blockchain or a 12-second blockchain? What is the length of my block? I think that's reasonable. What is like this existential deposit? What is the SS58 version number? And what is like the runtime version specification? These are the few things that I want to create some. I want my users to specify, but I don't want my users to specify with the other, like 50 parameterizable things that most of the time they copy paste and they don't really care about. So to achieve this, the code for this is a little bit like complicated. I invite anyone to go and have a look later. But in short, it's using the same set of macros that I was talking about to create some default configurations for a number of pallets. So I create like a default configuration for frame system. And I create a default configuration for timestamp palette. I create a default configuration for, okay, this is still timestamp, for the Aura palette. And same with balances. I create a default configuration for balances palette. I create a default configuration. Okay, that's actually it. So I create these default configurations, and these default configurations I'm creating, they are only generic over some F that implements this main Flite config. So I'm basically freeing my user from needing to specify configuration for all the palettes and only provide this, and this guy will take care of the rest for them. So let's look at how this will actually work in action. So I have like a runtime that has been created with Flite, and I hope you can see how simpler the code for this actually ends up being. So this is a fully functioning frame runtime. I am using this new version of the sort of construct runtime macro to specify what palettes are in this runtime. So I have system, the original frame system. I have Flite system. I have the Aura palette, timestamp palette, and balances palette, which are exactly the palettes that at the moment I'm providing some default configurations for via Flite. And I'm also adding this demo palette that we have in the repo here. And then I only need to specify a few things, like the version of the runtime. You have to specify these things like spec version and so on. My block time, my block weight, my version. And I just create one struct called configuration, and I implement the main Flite configuration for it. So again, this main Flite configuration was like, just 5-6 reasonable things that need to be configured. And then once I have this configuration guide that implements Flite configuration, I can derive the default for everyone else. And this is the magic. This is the sort of the beauty of it. I can say, hey, I have frame system in my runtime. Great. I'm just going to say derive the implementation from Flite frame system of this configuration. I have, okay, this is the Flite system. It has actually nothing in it. I have a bit of, I think, ugly code from the past here. I can move it on top. Sorry, 1 second to just clean up these guys. Okay, next one. I have timestamp palette. Great. Derive the implementation from Flite timestamp, which is itself parameterized by this configuration struct that I just created. Same with Aura and balances. And again, all of these things can sort of, you can always overwrite these configurations by just adding more things here. If you happen to want to like overwrite the max locks of palette balances because whatever Flite was giving you was not a good choice, you can always override it. In some sense, I would like to try and visualize it as such. We have all of these very generic palettes like frame system, and let's make this a bit, let's make this guy a bit smaller and bring it here. You have all of these super generic palettes. So frame system, palette balances, palette Aura, and so on. And these guys are extremely flexible. So maybe I can make them be, I don't know, a dash line to make a difference. And you have to, specify a lot of configurations in order to use them. What Flite is doing is trying to be like, one wrapper on top of all of them. And this one is dashed line because it's a bit more concrete. It's like not as, wishy-washy. It's not as, as generic. So Flite asks you to give it, let's visualize it like this. Flite sits on top of this and asks you to just give me one configuration struct that is only, configuring a few things. So let's put a plus sign here. And you're adding like, one configuration. Configuration. Let's make them a bit smaller. So Flite is saying, hey, you as the user, just give me this. So user just gives us this. And we, under the hood, automatically give you good, reasonable configurations for all of these guys. And there's no limit to this. Again, what I've built here with Flite is just a demo. Like I'm demonstrating that this is possible. And I'm hoping, if this is valuable, more people go and build it or build more meaningful things on top of it. We automatically implement all of this for you under the hood. So this is basically the sort of architecture of what Flite is aiming to do. Oops. This look a little bit nicer. Right? And then, again, the nice thing about all of this is that I'm not changing frame in any way. You can still access all of the generic types that were in palette balances. And again, 99% of users don't care about. But if you're in that 1% user group that does care about this, you can access it. Or again, as I showed here, if you actually want to, if you don't like what Flite Balances is doing here, you're absolutely free to override it. You can provide your own weight info type here. So give me 1 second to close my door. All right. And similarly in your palette, so what is like the user journey here? So at the runtime level, so this is actually on the runtime level. At the runtime level, you provide this one configuration, and that's it. You give one config, we implement all the rest. So this is at the runtime level when you're parameterizing the runtime. At the palette level, let's put it here. At the palette level, we have this Flite system. So we're saying your palette, instead of relying on, let's put it like this. So we have a user palette or your palette. And your palette, instead of, relying directly on frame system and then palette balances through another trait and blah, 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 you can just rely on Flite system. And what Flite system does is giving you a nicer interface to, again, all of these guys, such that you can access them, but in a more user-friendly manner. So again, you have access to all the power and flexibility of Frame. It's just that Flite system and this sort of Flite configurations are a nice wrapper around it, such that working with it is a little bit easier. All right. I think I'm at the end of my presentation overall. I will finish with a few sort of next ideas. Again, I didn't cover everything to do with Flite in detail here. I think I touched all the parts, but of course there's more detail. But I've tried to document this fairly comprehensively, and the code is also relatively clean and well documented. So I hope if anyone gets interested and wants to jump into it, it's a good code to try and learn and so on. There's a lot of documentation around it. Especially in this file, it's all the things that I'm showing. And in fact, what I want to close on is what I think are further ideas that can be implemented. So I have made an example of palette balances being simplified by Flite, but truthfully, I haven't thought a lot about it. And I think one of those key pieces that we can pretty much assume every runtime out there needs is a nicer interface over balances. So building a better sort of abstraction over both pallet balances and pallet assets, which is the more generic form of it, I think would be a good step forward. I haven't covered like all the baseline pallets. So I think timestamp is one, aura is one, but session and authorship are also two pallets that are almost in every runtime. So it's pretty reasonable for Flite to just give some defaults for that, give some parameter, give some abstraction over it. And finally, I think this is the most important one. So, I mean, what I've built here is more for like solo chains, normal blockchains. But I think if someone builds like a Flite parachain, like a parachain compatible Flite, and actually then build a parachain with it and maybe deploy it to Kusama or something where it's pretty cheap or relatively cheap. Or we can also like fund this with like a treasury, enough treasury funding to like get core time on Kusama for a month and launch something. I think this is pretty doable and controversial. I think having Flite to be parachain ready would be the most important next step that I haven't done myself. And I hope some of you guys would be interested in doing that. Yeah, and there's a few other ideas, but I think I won't go over them because they're not as important. All right, so that's it from my side. I'm happy to now answer any questions, or yeah, then we can finish it up.
Yeah, thanks for that, Kian. If anyone has any questions, you can either voice it out or paste it in chat and I'll interact with it. I think in the chat, already. Someone asked,
yeah, feel free.
What advantages does the Flite abstraction in Polkadot SDK offer for developers' experience?
Yeah. So it's like I would say it's like three things. If the vision is completed, I mean, right now again it's incomplete. But one is that instead of dealing with generic types, you would often work with concrete types. You will no longer have. Let me show you this again. You will no longer be dealing with like, oh, T as frame system config account ID, which is some generic type, and you don't really know what it is. You will be dealing with concrete types. And I think this is indeed a nicer developer experience. The other one is fewer configurations. So at the runtime level, I mean, look at this runtime. It has like 5 pallets, and the overall configuration for those 5 pallets is like this many lines of code, like 30 lines of code. This is not how a normal frame pallet is. A frame runtime is. To parameterize 5 pallets, you usually need 500 lines of code because there's so many parameters that you have to think about. And Flite is kind of giving you a reasonable default, so you don't have to care about it. And I think the third developer experience advantage is that if done right, these defaults would also be safe. They would be safe and sane, you know? Because when you have to parameterize pallets and you have to parameterize everything yourself, you very often make mistakes. But Flite can aim to, you know, nail it once and then make it good for everyone afterwards.
Nice. Thanks for that. I hope that answers your question. If there are like any more questions, you can speak out, or as I said, type it in the chat and we would address all of them. Okay, I think that was everything. So, sorry, I think someone wants to speak. Bypass. Do you want to say something? Your mic is unmuted. We can't really hear you if you're speaking. We can't really hear you. Maybe try like typing out your question or fixing up your mic and then get to your question. Okay.
Yeah. I hope you all have learned something about, especially I think this demo crate. By the way, I just pushed this to the repository as well. I think this demo crate is also something that, yeah, even if we forget about Flite, I think this was the main thing I wanted to talk about today. Like, if you really play around with this and understand this, I think you will have actually a much easier time with Frame anyway. And then you can see if, this idea of Flite resonates with you, and it's something that people want to like hack on and continue developing. I'm presenting this Flite here more as a demonstration that, hey guys, look, these techniques and these simplifications are possible, and here's one example of it, and you guys can apply this anywhere in your work, or feel free to open PRs against Flite, or make a fork of it and push it to completion, whatever you wish.